Hi, today I will discuss one question from GATE 2022 in CY. GATE 2022, GATE CY, question number 4. So this question is given as that a substrate is given at your screen, which is looking in your screen. The substrate is given, which is treated with a base, that is LDA base. LDA base is lithium isopropyl amide. Lithium diisopropyl amide is a very strong base, and you have to use inert and low temperature to use this base. After that, it is given an alkyl bromide, which generally forms P, and then this P which reacts with Grab's to mean second generation Grab catalyst, followed by reduction with lithium brohydride to form Q, and options are A, B, C, D. Now the question is actually a very simple question. Base is given, so you can easily understand the base will abstract this alpha hydrogen as it forms the enolate ion. Then that enolate will attack this alkyl bromide, only alkylation, to forms the P. Then it will undergo olefin metathesis by Grab's second general catalyst, and then undergo reduction by lithium borohydride. So we cannot get to know the options without undergoing the evaluation of this question. So let's start. So this is the question which is given to us, and now what first we have to know, we have to know about chiral auxiliary. We have to know about this. So this chiral auxiliary, this is all. What is a chiral auxiliary? Chiral auxiliary is a stereogenic group which is temporarily inserted into the compound to maintain stereochemistry. Means it is saying that in a reaction, if we want to have a chiral environment or to proceed a reaction through a chiral one, then we have to insert a group which actually helps us or helps the reactioners to maintain the stereochemistry of the compound and to proceed the reaction, and after that if we treat it with any other reagent, that group will easily cleave it out. For here example, this is a chiral auxiliary group. What is this chiral auxiliary group? This is the auxiliary ring having a isopropyl ring above the ring. Isopropyl group is attached to this ring from above position. So now if any reaction is going to happen at this position, because our reaction will happen at this position, then it should come to the down, because all other is in plane, this group is also above, so the above position is low, so it will come from below. And afterwards, if we just reduce it with means hydrolyze it with lithium hydroxide or reduce it with lithium borohydride, this group will go out. Now, LDA, it is a base which abstracts proton from the alpha position, forming the enolate. So how the enolate is formed? So we have to know how the enolate should form. So here this is the substrate which is there. This base is abstracting this proton. This bond is giving to this position, and this bond is formed where there is a formation of. So this in this plane, this is above the plane, and this is the enolate which will be formed like that, whatever I have written it here. Now we have to always be careful when we will be doing the problems related with events chiral auxiliary. You must have to see that these polarity, this dipole of these groups and these groups should be on the same side. Then you can decide the stoichiometry very easy. Now what will happen? This enolate will form. So when this enolate will form, lithium will be only in the reaction medium. So O minus will coordinate with the lithium, and this oxygen will form a weak bonding with this lithium, forming a 6-member ring, which is stable. Now the above position is blocked by this isopropyl group. So when it will keep, it will attack from the below position. So whatever group, the alkyl group will going to be inserted at this position will become from below. This product is forming where this group is below and this group is above the ring. Okay, so the first part of the question is solved. Next part, what it asks, next part is that when the B will reacts with Krafts 2 catalyst and followed by lithium borohydride reduction, it is giving. So what is our P? This is our P and this is our reaction conditions. Now we have to know about Krafts catalyst. Krafts second generation catalyst. So nothing to deal with the second generation. All the Krafts catalyst actually helps in olefin metathesis. First generation or second generation. So it is actually like this type of catalyst where the metal is actually with the alkene ring having double bond. Now if we compare this in a simple term, so we can write it like this way, which reacts with the alkene moiety to form this 4-member metal cycle, which actually when the alkene will leaves behind to form this second intermediate. Now this metal intermediate will react with this alkene to form this second metal cycle. In this case, the alkene will go out. It can be E or Z, and this will go out, continuing the reaction cycle. Basically, it is actually like this. If R1 is this R2, it will react to form. It will breaks to form a double bond between this group and this group. So if we do this chemistry here, then what will happen? This is one of the group, this is another group. So it will have a double bond at this position, and these two double bond will go away, forming the, for giving us the structure this, that we have a double bond at this position where this double bond and this double bond got out. So we have a double bond at this position. Now what is the stereochemistry of this position? The stereochemistry of this position is R. How we will get it? This is A by C2. This is A, this is B, this is C, and hydrogen is above the plate, so it will be R. Now when we have a reduction, lithium borohydride reduction, first it will go to form the first it will form this what we call acid, and then acid will not be stable, it will directly give us alcohol. So whatever the reagent is used, we give a detailed mechanism whatever is used. Now this is the question which is given to us, and in both the cases it will be down. So here and it will be here. The answer will be B. So for further clarification or further learning about this, you can watch over the stereochemistry videos by Dr. Amit Basak from IIT Kharagpur. Amit Basak, and also you have to look into the enol and enolate alkylation by Dr. Niraja Dasputre and Harira Chakrapani from IIT Pune. After showing these two videos, you can understand what is this chiral chemistry and how it works and whatever. Thank you.